I want to start with a reminder that the idea behind these videos is not to replace your attendance in class with a lecture, but to try and replicate to a small extent the experience that the students that were in class on the day that we did this lesson had in the classroom, which is not a typical lecture experience. For this lesson, I gave the class this function, L of x equals x plus 3. And I may or may not have explained during class that I chose the letter L for this function because this function is a line, and that's going to help us remember that this function is the linear function. We'll see some other functions in a minute. So that's why it's called L of x. And the instructions were to evaluate this function for the following inputs. There were several inputs, including 0, 1, -1, -3, and -4. So how do you do that? Well, we're looking at these are the input values that we're going to put into the function. So for example, I would have L of 0 equals, and I'm going to replace the 0 with the x with a 0, and I'll get, excuse me, I'll get 0 plus 3, which is 3. So now what I'd like you to do if you're watching this video is do the same thing for L of 1, L of -1, L of -3, and L of -4. Pause the video, figure out what these values are, and then come back and I'll tell you what the answer should be. For L of 1, you should have got 1 plus 3, which is 4. For L of -1, you should have got -1 plus 3, which is 2. L of -3 is -3 plus 3, which is 0. And L of -4 is -4 plus 3, which is -1. All right, so hopefully that's review. The next thing we're going to do, or the next thing we did in class, was to repeat this exercise for a different function. So I'm going to give you a different function now. We're going to use these same values. We're going to do the same thing again. Our new function is r of x, is the square root of x plus 3. So it's still the x plus 3, but we're taking the square root this time. And the r stands for radical. Okay, just again, to help us distinguish the two, we're talking about this is the linear function, this is the radical function. All right, so we're going to do the same thing again. We're going to find r of 0, r of 1, r of -1, r of -3, and r of -4. Go ahead and take a minute and figure out what those values are. Pause the video, and once you know what your answers are, come back and I will share with you what they should be. As with many things in mathematics, there are a couple of different ways you could have done this problem, this series of problems. One is that you could have taken a 0 and plugged it in for x in the function r of x, which would give you 0 plus 3 in here, and then you take the square root of that, so that's the square root of 3. The other way you could have approached it is to say, well, the inside here is what I got when I did L of x, right? When I took L of x and I evaluated at 0, I got 0 plus 3. And so what I'm doing is evaluating that same thing at 0, so I'm going to get the square root of whatever I got back here. So with that in mind, the answer to r of 1 should be the square root of 4, which is 2. R of -1 is the square root of -2, which is I root 2, for those of you paying attention. The root of 0 is 0, and the root of -1 is I. So those are the answers for r of x. We're going to take a look at another function now, q of x, and we're going to do the same thing again. Q of x is x over x plus 3. We'll do this one down here. I'd like you to find q of 0, q of 1, q of -1, q of -3, and q of -4. Go ahead and pause the video and work out what these values are. When you plug a 0 in for x here and here, you get 0 over 0 plus 3. So you should have 0 over 3, which is 0. Plugging in a 1 gives you a 1 over 1 plus 3. That's a 1 over 4. Negative 1 as an input value gives you negative 1 over negative 1 plus 3. That's negative 1 over 2, which can be written either as negative 1 over 2 or just negative 1/2. I'm going to skip the next one. Q of negative 4 is negative 4 over negative 4 plus 3, which is negative 1, which is positive 4. And the last one is negative 3 as an input gives me negative 3 over negative 3 plus 3, which is equal to negative 3 over 0, which does not exist. That is undefined. Those are the answers you should have for that one. There are two more functions. I'm going to show you what those functions are, and then I'm going to give you the answers. The only reason I'm giving you the answers is because I'm assuming that you were not in class and that you're watching this video to get caught up. So if you have the answers, you'll be able to check your answers. This part's super straightforward. The next part that we do with the same functions is going to be a little bit different. So here are the two new functions. S of x equals x squared plus 3. S stands for squared. C of x equals x cubed plus 3. C stands for cubed. Q, by the way, stands for quotient. So I'd like you to evaluate S of 0, S of 1, and so on, and then C of 0, C of 1, and so on. Figure out what those values are, and I'll come back with the answers. Pause the video now and work out your answers. Here we have our template, and into these answer slots go 0 squared plus 3, 1 squared plus 3, negative 1 squared plus 3, negative 3 squared, that's 9, plus 3, and negative 4 squared, that's 16, plus 3. Into our cubic function, we have 0 cubed plus 3, 1 cubed plus 3, negative 1 cubed, which is negative 1, plus 3, negative 3 cubed, which is negative 27, plus 3, and negative 4 cubed, which is negative 64, plus 3, which is negative 61. So check that you got the same answers. If you didn't, go back and check your arithmetic. And that was the end of what we did for that piece. The next piece is also review. For part number 6, I'd like to use as the input for all 5 of these functions the value t. T is just a number we don't know. So I'm going to get L of t, R of t, Q of t, S of t, and C of t. Take a minute, pause the video, and see what you come up with by way of review, and then I'll come back and tell you what the answers are. Since t is just a value we're plugging in, we just don't know what that value is. We're going to plug it in for x. In L of x, we get t plus 3. In R of x, we get the square root of t plus 3. For Q of x, we get t over t plus 3. S of t is t squared plus 3, and C of t is t cubed plus 3, and that's it. We're just replacing the value instead of with a 0 or a 5 or a negative 7 with a number we don't know. So we can't actually do the computation, but we still have, we can still plug it in, right? All right, so that was it for that piece. For the next piece, I'm going to add another something for you to plug in, and that is t plus 1. So let's find L of t plus 1, R of t plus 1, and so on. All right, I'll do the first one with you, and then remembering that what we're doing in class is working in groups, and if you're watching this video, it's probably because you were not in class and so you don't have a group. You and I will be the group here, and I will just kind of remind you that, or think through with you, the idea that since every single one of these functions It's just a function in x where if you know what the x is, you just replace it with that value instead. We replaced x here with 0, with 1, with -1, and so on. We replaced it with t. So now what I'm going to do is replace it with t minus 1, sorry, t plus 1. So instead of x plus 3, I have t plus 1 plus 3. And that's it, except that I can simplify this. If I remove the parentheses, I get this, which simplifies to t plus 4. All right, take a minute, pause the video, see if you can figure out what the other ones are. You should have, for r of t plus 1, the square root of t plus 1 plus 3, which is the square root of t plus 4, and that is as far as you can take it. A quick reminder that the square root of a squared plus b squared does not equal a plus b. Okay, so please be very careful. Don't do that. A lot of students are still doing that. Not necessarily this class. This is our first lesson in this class. I haven't met you yet, but I have students in Calculus 4 who still make that mistake. So be careful. The next one is q of t plus 1. Well, my function q is x over x plus 3. So where I had an x, I'm going to replace it with t plus 1. S of t plus 1 is, let's see, s is x squared, s of x is x squared plus 3, so this is going to be x squared plus 3, but x is being replaced with t plus 1. And the same thing with the cubed function, plus 3. X cubed plus 3 becomes t plus 1 cubed plus 3. All right, take a minute now and go back and simplify this expression, and this expression. Pause the video, and when you come back, I'll show you what they are in their simplified forms. Q of t plus 1 simplifies to t plus 1 over t plus 4. S of t plus 1 simplifies to t squared plus 2t plus 4. You didn't get the same thing. Try going back and making sure that you're squaring this inside this expression here correctly. C of t plus 1 is t plus 1 cubed plus 3, and that simplifies to t cubed plus 3t squared plus 3t plus 4. Again, if that's not the answer you got, start by trying to make sure that this expression here, cubed, is correct. Make sure you cube that correctly, and then combine like terms. Okay, at this point, I'm going to give you a different expression to try plugging in. So number 8 is to evaluate all of these functions for t minus 1. So I'm going to erase a little bit here. I'm going to try. My eraser tool's not working the way I want it to. I'm taking out all my t plus 1s. Okay, and I'm going to replace them with t minus 1. And what I'd like you to do, if you're watching this video, is to go in and figure out what you think the answers here should be. Found another one that needs corrected, this one here. Oh, that one too. So I'm replacing all my t plus 1s, all my x's, which I had previously replaced with t plus 1, I'm replacing them now with t minus 1. Go through and figure out what the answers to these are, what the simplified version should be. Pause the video, and when you come back, I'll have the answers on the screen. Here are the answers to these evaluations. L of t minus 1 is t plus 2. R of t minus 1 is root of t plus 2. Q is t minus 1 over t plus 2. S is t squared minus 2t plus 4. And C is t cubed minus 3t squared plus 3t minus 3t squared plus 3t plus 2. If those aren't the answers you got, take a minute and go back and try to fix it. For the next one, I'm going to have you replace x with x plus 3. So go do that one and come back. I'll set them up for you, but I'm not going to walk you through them this time. Okay, I've emptied my functions. Instead of L of x, I now have L of x plus 3. So I'll replace all of my x's with x plus 3. So this is what you should have if you've correctly replaced everything, replaced all your x's with x plus 3. Instead of x here, instead of x here, instead of x here, I have x plus 3 in those positions. Okay, take a minute now, pause the video, work out what you think the answers to these ones should be, and when you come back, I will have the answers on the screen for you. So here are our answers. L of x plus 3 is x plus 6. Let's just pick another one at random here. S of x plus 3, which used to be x squared plus 3, is now x plus 3 squared plus 3, is x squared plus 6x plus 9 plus 3. So when you simplify that, you get this, and so on. So check those answers and make sure that you agree with what I have here, and then we'll do the next part. Okay, for question number 10, I'd like you to replace x with the square root of x plus 3. So these should look like this. Take a minute, pause the video, work out what you think the answers should be, and I'll come back with the answers. And here we go. There's not a lot we can do to simplify these ones. The square root of x plus 3, the x plus 3 is inside the radical there. We can't take it out, so we're stuck with just this expression here. Same thing with this one. The square root of x plus 3 is inside the radical, or the x plus 3 is inside the radical here. So within this bigger radical, this outside radical, there's nothing I can do to simplify that. So the only way to write this answer is like this. We could write it with fractional exponents, but in radical form, this is the only way to write that expression. Q of root of x plus 3 looks like this. The denominator here is the same as L of x, right? We get the same thing there. Nothing I can do with that square root. This one's a little different because I can square the square root. That simplifies to just x plus 3, and then I add 3 to get the x plus 6. And with this one, I can't write that either, any other way either, except, again, I could write it as with fractional exponents. I could write this as x plus 3 to the 1/2 raised to the third, so that would give me this. But then the plus 3 is on the outside of all of that, so I'm stuck with that form. Okay, it's time for you to try a couple on your own. I'm going to give you 3 more functions to try using as inputs. Number 11 is x squared plus 3. Number 12 is x cubed plus 3. And number 13 is x over x plus 3. I don't know if you've noticed, you probably have, that these are getting incrementally more difficult to work with. That's okay, that's kind of how this class is going to work. We start with the really easy stuff, everybody can do it, or you should be able to do it. This is like basically Math 98, plugging a value into a function and evaluating it. And they get a little harder, and they get a little harder, and then they get really quite challenging. Okay, so take a moment, take your, I don't know if you're using the same kind of template as I am, but you take out your current evaluation work that you've been doing and replace it with whatever the new one is. In this case, it's going to be, let's see, we did the square root one, so we're on x squared plus 3. We're going to replace everything with x squared plus 3. Once you've done 5 functions using x squared plus 3 as your input, start over, erase all of those, and do x cubed plus 3. Then start over and do all of those and use x over x plus 3. Okay, we're ready to take it up another notch. I'm going to rewrite my functions. L of x equals, so you don't want to write it that way, L of x equals x plus 3. So far it's the same as I did before. I'm just basically making room for whatever I decide to plug in for x. X plus 3, q of x equals x over x plus 3. And then I have s of x equals x squared plus 3, and c of x equals x cubed plus 3. And I'm just going to carry on doing what I was doing before, replacing x in this function, both here in its name and here in the actual function, with something else here and here. I'll replace this x, and this x with whatever I'm told to plug in. So I'm going to erase these values because I've run out of room here. And I'll start with number 14. Get my pencil to work here. For number 14, I want you to plug in L of x. All right, well, what does that mean? If you were in class, I would be asking you just to discuss it amongst yourselves and see if you could figure it out. I'll give you just a second to do that now. If you want more than just 2 or 3 seconds, then pause the video and think about it for a second. Okay, what does it mean to plug in L of x? Well, if I follow the same pattern as I was doing before, I could do this, L of x, L of x. Right? That's all I was doing before, was taking whatever I'd been told to plug in and plugging it in. Right? So I have L of x plus 3. But I know what L of x is. It's this function here. So I'm going to get x plus 3, which then simplifies to x plus 6. All right, but I need to do that for each of these. So now I'm going to do r of L of x. But I know what L of x is. It's x plus 3. So I get root of x plus 6. Okay, see if you can figure out what this one should be. I'll start by just replacing x with L of x. Take a minute, pause the video, and work out how to rewrite this using what you know about the function L of x. Well, you know L of x is x plus 3, so you can replace L of x, the name L of x, with what it is, x plus 3. So we get here x plus 3 over x plus 6. The last two, the same procedure applies. What do you get? You get L of x, whatever that is, squared, plus 3. And you get L of x, whatever that is, cubed, plus 3. Take a minute, pause the video, see what you get. This is going to be x plus 3 squared because L of x is equal to x plus 3. This is going to be x plus 3 cubed. This gives me x squared plus 6x plus 9, and this one is x cubed plus 3x squared plus 3x plus 30. Did you get those answers? Okay, let's try another one. For number 15, I'd like you to replace x with r of x. Every time you see an x in the original function, you're going to replace it with r of x. My pen is very slow. Okay, so r of x. What does that look like? Why don't you take a minute, pause the video, and see what you get. Okay, so hopefully you have something that looks like this. And now you can rewrite L of r of x, knowing what you know about r of x. What is r of x? It's the square root of x plus 3. Take a minute and finish these, and we'll come back. Pause the video and see what your answers are. Okay, hopefully you've come up with something that looks like this. Because I know what r of x is, I can replace it with, instead of its name, its actual, the function side of it, right? This is the name side of the function. This is the function side of the function, or the expression side. So I've replaced the name of the function with the expression of the function, and then I've simplified. The same thing here, take r of x, plug it in. What is r of x? Well, r of x is defined to be the root of x plus 3, so plug it in, and there's not much I can do with that. That's supposed to be a 3 right there. Doesn't really look like much of a 3. Pardon my slow pen, there we go. There's a 3. Yeah, if I replace x with r of x, then I get this, but I know what r of x is, so I replace the name with the expression, and then I can simplify. Again, there's not much I can do here. When I replace r of x with the expression, I get a square of a square root in this case, so I get x plus 6, x plus 3, squared and unsquared, so I get just x plus 3 here, plus 3 more. And this was the same as we had before with x plus 3, the square root of x plus 3, and then all cubed. Then I said, well, you could write that as x plus 3 to the 3 halves plus 3, but there's really nothing we can do with it other than that to simplify it. Now, I don't know if you've noticed this, but I've actually given you these before. I gave you the function x plus 3. It was number 9. When we did problem number 9 together, I asked you to plug in x plus 3. It's also question number 14, right? Because instead of giving you the expression, now I'm just giving you the name of the function. All right, let me give you a couple more for you to work on your own, and then we'll take it to the next level. Number 16 is evaluate each one of these functions for the input q of x. And number 17, use the input s of x. Now, if you've been doing this with us in class, you would have got even less guidance from me on this than you have in the video version. The main reason for that is that you would have been collaborating with your classmates, and you would have each other and, frankly, the internet to look things up on. The goal here is to get you to sort of discover what's sort of being taught here, and by discovering it yourself, you're much more likely to remember it and be able to apply it in the future. So I'm not going to give you the answers to the last couple. What I will do, though, is give you the next step in this process, which is something of a notational exploration. So let's take a look at that now. What I'd like you to try to figure out is, how would you interpret and then how would you evaluate L of S of x? How would you evaluate and interpret R of L of x? And how about S of L of x? Again, since you're exploring this on your own, I'm not going to give you too much here, but what I will do is, for the first one, I'll give you a hint to get you started. Now, maybe you've already seen it, which is great if you have, but let's just pretend that you haven't. If you want to think about it for another few seconds before I tell you where you should be going next, or how you might interpret this, then pause the video just for a few seconds and think about it, and then restart it again. The notation L of S of x just means the function L with s of x plugged into it. Well, we know that the name of a function is s of x means that its expression is x squared plus 3. So hopefully you see the parallel between this notation and some of the things we did on the previous screen or in the previous group of exercises. So see if you can take that to its next logical conclusion. And then see if you can do the same thing for r of L of x and s of L of x. Once you're done, come back and I'll show you the next step. Did you figure it out? Well, we know that the function L of x is x plus 3. So I'm going to replace my x with x squared plus 3. X squared plus 3 is my input here, as shown here. If I just, let me circle it maybe. I'll use a highlighter. If I just had this, then I would interpret that to mean take the function L, which is x plus 3, and replace the x with x squared plus 3. If I go back a step, I see that I was given L of s of x, and all I've done here is replace x with the function s of x in its expression form rather than its name form. So I've replaced the name of the function s with the expression of the function s, but either one of those, in either one of those forms, it's still the input to the function L. All right, see if you can figure out what the second and third ones are, and then I have some new notation to show you. Based on what we've done here, what do you think L, that's a little open circle, S of X might mean? What about S, little open circle, L of X? How about R, little open circle, Q of X? Really, all you can do here is speculate, but hopefully the patterns that you've been seeing, the applications we've been using, the idea is that they would lead to this. And this is a notation that has been assigned to this operation. And so it's not something you could guess. You have to be told what it means. But I'm hoping that you can intuit what it means from what we've done here. All right. So between now and the next time you come to class, give some thought to what this notation means. Sometimes you'll see it with parentheses around the L circle S, S circle L, R circle Q. I could do this with any of my functions. For example, I could do C circle Q. I could do C circle R. I could do S circle L. I could do S circle Q. I could do R circle S. I could do any pairing, any combination. So see if you can figure out what this notation might mean based on what we've been doing. Now, at this point, I don't really know how far we might have gotten in class because I'm making this video before we've actually met for class. If we have time, I will do a couple more things. Some of these are a little less important than others, but there are things that if we have time, we'll bring them up and we'll see how far we get with them. So for example, one thing you might see is, this is an example of one of these, C of L of S of X. What do you think that means? What do you think R little circle S little circle L of X means? All right, so that's one thing. These are obviously related. okay? But how they're related and whether they're related to each other or just related in general, that's for you to try to discover. So that's one thing I wanted to talk about before we quit this video. The other has to do with domain. My hope is that you remember how to find the domain of a function, and I'm going to go with the function q of x, which is equal to x over x plus 3. The domain of this function is the set of all real numbers x, as long as x is not equal to negative 3. Now that's a fancy way of writing it. You could also just say x can't equal negative 3. That's kind of the shorthand. Either of those is fine for me for this class for now, but it's important that you know what that means. All right, so now that you've found the function q's domain, let's take a look at the function r. The function r is the square root of x plus 3. The domain of this function is all the numbers x, as long as x is greater than or equal to negative 3. And the reason for that is that if x is less than negative 3, if it's equal to negative 3, then you get negative 3 plus 3, which is 0. That's the square root of 0. That's not a problem. But if it's less than negative 3, say negative 4, or even negative 3.2, then when you add these two together, you're going to get a negative number. And we're dealing with functions in the real numbers. These are polynomials or polynomial-like functions, functions that behave a lot like polynomials. We'll talk more about that later. So we want all our answers to be real numbers. And so if I take an x that's less than negative 3, like negative 4, that's going to give me negative 1 here, and that gives me the square root of negative 1, which is not a real number. Okay, we'll talk about that later as well, but for right now, we just want to stick with the real numbers. So we can't use numbers that are less than negative 3. Now, what is the domain? This is the big kind of culminating question for you. I do have a couple more questions just to round things out, but for this piece anyway, find the domain of the function that you get when you do this. Q of r of x. What about r of q of x? Find the domains of this function, the one that you get at the end here once you've actually done this operation. And I'm having to put my my little equal sign and my question mark up here because on my screen, and you can't see it, right here, there's a button that if I push it, weird things happen. So I've just written above that little button. So what happens to the domain? You know what the domain of R is. What's the domain of Q of R? And what about R of Q, right? So give that some thought. The next time we meet as a class, we're going to be talking a little bit about this, a little bit about, I don't have an example up now, a little bit about this notation, not necessarily the one with 3 letters in it, although if you have questions, I'm happy to address those. And a little bit about how these two notations are related. Remember I said a minute ago that the two expressions are not necessarily related directly, but this notation and this notation are somehow related, and I'm going to talk a little bit about that too. So those are the 3 main things that we will discuss the next time in class. The assumption being that if you were in class, you would have, essentially by the end of the class period, you would have learned what you needed to learn about what we did, taking a function like this and replacing the x and replacing what to replace it with and what to do once you'd replaced it, all that kind of stuff. So we'll be talking about these things: domain, this particular notation, although not necessarily a three variable or 3 function notation, and how these two notations are related. And we'll also talk just a little bit about the nomenclature of the vocabulary associated with this operation, right? This is an operation. You're taking a function s and you're doing something to it. You're applying L to that function. And then in this particular case, because you've got 3 of them, you're applying C to that function. So what does that notation, what do we call that notation? So once you've absorbed what to do with this thing when you see it, this thing right here, or this thing right here, once you know what to do with it, we need some nomenclature, we need some vocabulary around that. That's another one of those things that's standardized. It's not really something, you could make up your own name for it. That's absolutely fine, but somebody else might not know what you were talking about. So many hundreds of years ago, probably, the notation for these things was established. And so in order to be taken seriously as mathematicians, we need to know what that vocabulary is. So that's it for now. This video is a little longer than I intended for it to be, but keep in mind that if you were in class, we probably would have gone through all of this content considerably faster than we did here, because I was kind of taking you through it in a lot of ways. In groups of 3, or rarely, but occasionally, possibly 4, you will have 2 other classmates, yourself and two classmates, each of whom can draw upon the knowledge and experience of the other 2. And so this process may go a lot more quickly. You're also allowed to look things up on the internet. You're allowed to collaborate between groups, and you're allowed to ask me questions, although I may or may not answer them directly, because the point is for you to discover. So that's going to do it for this video, and hopefully the ones that I make in the future won't be as long. Cross your fingers. I can't promise, but that's going to be my goal.